Before I get started, I'd also like to say thanks to the rest of the SDL and BlueHat teams for inviting me to this conference and giving me the opportunity today to share with you a little bit about EMC's experiences with threat modeling. Just a quick introduction, I work for EMC in the Product Security Office, which is a central organization responsible for security. I'm on the SDL team there, and one of my responsibilities is to lead the design phase of EMC's SDL. Quick outline of my presentation today. I'm going to start with a little bit of background on security initiatives at EMC and how threat modeling fits in among those initiatives. I'm then going to share with you our initial goals in rolling out threat modeling throughout the corporation and some of the challenges we encountered in doing so. I'll then get into some details on our threat modeling approach, how we create threat models at EMC, and I'll wrap up with sharing some of the results from threat modeling at EMC. So company-wide product security initiatives started at EMC around 2004 with the formation of a central organization that was responsible for product security. And what we've done to drive security initiatives throughout the corporation, for the most part, is use a product security policy. Today our product security policy consists of around 80 requirements that product development organizations are expected to implement. These include both functional requirements around features that customers demand in the products, as well as non-functional requirements around activities that are recommended being implemented in the development lifecycle so that security can be built into a product. Threat modeling is one of those activities that we recommend. We recommend it's done during the design phase, that you do it to identify and mitigate security issues early in the lifecycle whenever possible. Around a year ago is when we really started rolling threat modeling out throughout the corporation, and our goals in doing that were to get the benefits from threat modeling. It's a proactive, cost-effective way to deal with security. If you identify and fix things up front, it's less costly than waiting and being reactive. We also wanted to start a cultural shift within EMC. And we want to develop organizations to start recognizing that security is an integral aspect of software design. Now, in reaching these goals, the biggest challenge was the diversity at EMC. EMC is a large corporation, a decentralized organization. We have development organizations throughout the world. They have varying levels of security expertise. Some of them have little or no security expertise. Some have actually pretty good security expertise. And they also do things differently. Each team has its own methodologies. Some are using agile methods. Some are doing more traditional software development methodologies. So a big challenge for us was to find a common denominator, something that could apply to the majority of these product development organizations within EMC. When we initially started with threat modeling, we tried using some of the publicly available methodologies, such as various revisions of Stride and Trike. Some of the common challenges and perceptions with these approaches were that they require security expertise. So these methodologies require you to do things like define trust boundaries, which is a concept that is hard for some developers to consistently apply. And also, at times, these approaches require you to think like an attacker, basically switch your hat, look at your system from an outsider's perspective, and try to break it, which is easier said than done. It requires a certain type of person to think like an attacker, and it requires a certain amount of security knowledge to do that effectively. Even when we found the security expertise within a product development organization, or we provided that security expertise by including somebody to help the development organization get through the threat modeling process, these approaches were perceived to be academic in nature. A lot of the time when you're doing threat modeling with these approaches, you're not finding anything interesting. They are comprehensive approaches, and at the end of the day, you will find threats, but a lot of time is spent not finding anything interesting going down, and it led product groups to question the efficiency of these approaches. They're also considered open-ended. A lot of times product development organizations would wonder, where do I stop? When am I done threat modeling? When do I know I've done enough? And now security people, they could threat model all day. They'd enjoy that. But developers tend to have more important things to do. Security is just one of many pressures on an average developer. And something that's open-ended is not very pragmatic. So taking these early lessons, our guiding principles going forward were to create a threat modeling approach that was easy to use, that didn't require security expertise, that could be used by an average developer or software architect within EMC. We wanted to create something that was closed-ended, not open-ended, something that you could see the clear finish. And we thought a checklist-based approach would be good for this. We say, well, just do these things. Once you've done these things, look for these things, you're done with threat modeling. If you want to do more, if you want to be creative and think like an attacker, you can do that, but at a minimum, just do these things. We also wanted to leverage a central community knowledge base. So as I mentioned, not every product development organization had security expertise, but there were pockets of security expertise throughout the corporation. We wanted to find a way to tap into those pockets and share it with the rest of the corporation. This slide outlines our approach to threat modeling as it is today. It's a four-step approach. First step in threat modeling is to identify an attack surface. And this is just a simple whiteboarding exercise drawing a data flow diagram. When I say attack surface, that's a security term, but it's easy to translate that into development terms. Your attack surface is basically all the entry and exit points to a system. Underlying principle here is system can't be attacked unless it can be interacted with. Therefore, every interaction point could potentially introduce or amplify threats. So attack surface at the end of the day is just your code and all the entry points. The API, network interfaces, user interfaces, certain key configuration files that you read and write to. Second step is to identify threats. This is the step that we found the hardest for product development organizations to do without security expertise. What we've done to make this easier is we've created an internal threat library of very common weaknesses found within software systems, and we recommend product development organizations go through this library to find weaknesses within their software architecture and the threats that they enable. I'll share more details about this shortly. The third step is to assess the risk of threats. Now, once you've gone through the threat identification process, you might find a lot of threats, especially if you have a mature product that's evolved over time and it has a little bit of baggage. You can find a significant amount of threats, and you need to prioritize to determine which threats you should address first and which you can wait a little while before addressing. To aid in assessing the risk of threat, we've created a simple tool that's based on CVSS, the Common Vulnerability Scoring System. That's a security industry standard way of assessing the risk of a vulnerability. We've added an abstraction around this tool. We've created a simple interface where the tool takes in the answer to 7 yes or no questions to generate a risk score and a risk rating. The last step is to plan mitigations. To aid in this, we've created, within our threat library, we have prescriptive guidance on standard mitigation techniques for each of the common weaknesses and threats. And we also have common security technologies available from RSA. So RSA has various toolkits that help product development organizations incorporate access control, encryption, key management, audit logging, things of that nature into their products. So they don't have to write the security functionality themselves. They can rely on proven solutions. So the first step is data flow diagrams. This is pretty familiar. Very simple way of representing a system, getting a visual representation of its attack surface. A couple of elements in data flow diagrams. Circles represent your code, basically, things that are in your control. Rectangles represent things that are out of your control, users and external systems. Data stores, places where data rests, and data flows show data as it moves through the system. What we've changed here is we've eliminated, we don't ask product development organizations to annotate trust boundaries in the data flow diagram. We take the approach that there's trust boundaries all over the system. Between any element in the data flow diagram, that some trust boundary of some sort is being traversed. It's implicitly there. We don't ask product development organization to annotate it. What we ask them to annotate is security controls. So where do you have controls in place that allow you to trust incoming data or assure the protection of outgoing data? Things that make up your security architecture. Security controls include things like authentication, authorization, data validation, and secure communications. This shows a simple data flow diagram. As you can see, it gives you a quick visual representation of the system's attack surface. In this case, the attack surface is a couple of user interfaces, a service interface, inter-process communication, certain key configuration files, and processes and daemons that make up the system. By including security controls in the data flow diagram, you can get a quick indication of gap areas in the system. In this case, the system has security on the perimeter. There's some user authentication and authorization. But if you look deeper in the system, you don't see any security controls, and this is generally a bad sign. One of the most common causes of vulnerabilities today is lack of input validation or data validation, and you'd expect to see a lot of data validation going on within a system that has a lot of inter-process communication, such as this one. This slide summarizes our threat library, our approach to threat identification. What we've done is we've created a threat library based on CWE, the common weakness enumeration. What CWE is a dictionary of software weaknesses. There's around 600 or 700 entries in this dictionary. A lot of them are fine-grained, very specific coding errors, but there are a few that are design-related issues. So we've gone through CWE and we've taken out the elements that we believe can be identified and mitigated during the design phase, and we've used that to create a threat library. We've supplemented that threat library with the results from past threat models at EMC, as well as with results from security assessments that we perform on products before they're released to customers, and with our experience with vulnerabilities in the field, things that we've discovered that have been discovered by security researchers or by customers after a product is shipped, and we've used that to supplement the threat library. This threat library is open for contributions from development organizations without EMC. It's maintained in a wiki so that development organizations throughout the company can add entries to it or make modifications and changes to the threat library. So this is a portion of the threat library. It's indexed by data flow diagram element. So if you have a data flow diagram, you can quickly go through and find the common weaknesses in that element and see if they apply to your system. We include entries for all data flow diagram elements, including security controls. So there are certain weaknesses that lead to second-order threats. If you have a flaw in your authentication system, for example, there are various ways that could be bypassed, and we include those in the threat library as well. For each weakness, we have a description of the threat that weakness enables, and a CVSS risk range so you can get an early indication on what the risk of that threat is. We also have potential mitigation strategies, so prescriptive guidance on how to deal with that common weakness, as well as a reference to external information for those that are interested in learning more about the particular weakness. For assessing risk, we have a simple tool that takes in as input the answer to 7 yes or no questions to generate a risk score. The first 3 questions are on impact, 3 types of impact: confidentiality, integrity, and availability. If you answer no to all 3 of the first questions, then there's negligible risk and we don't consider it a threat. If you answer yes to any of those 3 questions, then the next 4 questions are around exploitability. Who can exploit the weakness and how? 2 aspects to exploitability: accessibility and complexity. Basically, who can exploit this weakness? Is it an anonymous user, an authenticated user, or an administrative trusted user? And can they exploit the weakness locally or remotely? So things that are exploitable locally are less exploitable than things that are only exploitable than things that are exploitable remotely. The last question around complexity is whether the attack requires compromise in outside systems. So things that require compromise in outside systems are generally harder to exploit. And some common examples of that in EMC are software products that run on an operating system, and there are certain weaknesses that can only be exploited if the underlying operating system is compromised. And not much you can do about that. Other examples are when routing and DNS is compromised, there are certain vulnerabilities that are exposed. We take the input to this tool, we run it through CVSS and generate a risk score. The score that we generate is at times higher than the raw CVSS score because we've constrained the interface and limited the input. We've traded off simplicity and usability for accuracy in that sense. We also take the score and we map it to a qualitative risk ranking, high, medium, or low, so the product development organization can determine how risky that particular vulnerability is. So this slide summarizes some of the results from threat modeling at EMC. In the last year, we've had 7 product development organizations adopt threat modeling. Threat modeling is not mandated at EMC. It's highly recommended. So these groups that have adopted threat modeling have opted in to use threat modeling. Some of the results from threat modeling: on average, we found 5 high-risk issues and 2 medium-risk issues during a threat model. Tried to find some data to compare our results with. I wasn't able to find a lot. I did find one paper that AtStake published several years ago, and in that paper, based on proprietary research that AtStake had done at the time, they had come to the conclusion that on average an enterprise application has 7 significant security issues that can be detected and eliminated during the design phase. And they don't provide a lot of information on their research methodology, so it's not possible for me to do a direct comparison, but that suggests that our approach is effective and it is finding the things that you can find early in the development life cycle. We've also seen a cultural shift. Threat modeling is gaining traction at EMC. Of those 17 product organizations that have adopted threat modeling, 12 of them have done so in the last 6 months. We're also seeing software teams taking more charge of the threat modeling process. That product developers, I've seen cases where product development will move to another development organization, introduce threat modeling, advocate it, and it's gaining traction with the teams. There's a growing level of comfort with threat modeling. I think product development organizations are seeing clear value and benefit from it. They're seeing that it's not as burdensome or academic as it was in the past, and they're getting pragmatic results from it. Now that we've found an approach that works, our current focus right now is on enabling knowledge transfer. So we do have our threat library open for contributions for everybody within the company, but most people are just consumers of that threat library. There's not a lot of contributions. We're trying to look at ways on how we can foster a community and have more collaboration and more knowledge transfer within the company. That's it for my presentation. Are there any questions? Or are we waiting for questions till the end?
That's a great question in itself. Actually, what we're going to do, Danny's going to stick around, and then Adam's going to present kind of the Microsoft Counterpoint. And then after both of them are done, we've saved 10 or 15 minutes for questions from the audience, and you guys can grill them both. So thanks, Danny, and welcome, Adam.
Thanks, Danny. All right, let's... Okay, so we're still black. Oh, we have slides. Excellent. Minor threat of not disclosing information there. So I was going to start out by talking about the SDL threat modeling processes, but when I got Danny's slides, the thing that really struck me was how much we had converged and how similarly we had solved some problems. So I'm going to start out with a very, very fast presentation of the SDL threat modeling approach and then focus on some comparison between the two approaches so that you can understand where they're similar, where they're different, and then give you a demo of the new SDL threat modeling tool, which we are releasing a release candidate today. Very happy about that. And we'll show you the new features and where to get it. So to start out with our threat modeling approach, we, like EMC, like most threat modeling approaches, we're software-centric. We focus on what are the things which you are building, draw a whiteboard-level diagram, use that diagram to identify threats. And we use a methodology of stride per element, where the various stride threats, which many of you may be familiar with, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, apply to the different elements you've drawn in your whiteboard level diagram. When talking about this inside of Microsoft, I talk about this being the set of issues which you should look for. And these are ones for which we would often ship security bulletins. But we've got a lot of members of the extended security community here, and so I want to draw attention to the fact that this chart works for us. It might not work as well for you, and you should test it. Are these the things we care about? Are these the things for which we're updating? One example of this is to think about information disclosure by external entities. That sounds a lot like a privacy breach that will be in the news. It's something that we have other parts of the SDL. Our privacy experts will look at those things. We do privacy assessments to determine risk. So we don't replicate that into our threat modeling processes. But as you think about this, not just as a Microsoft thing, but as a thing that can be picked up and adopted around the industry by a variety of people developing software, it's something to think about. Oops. The mitigation step, much like EMC, we talk about redesigning to eliminate risk. We talk about standard mitigations. We talk about custom mitigations and why those are risky. And we talk about when it's possible to accept the risk in accordance with SDL bug bar rules. We have a validation stage. I think it's very important in giving people comfort with the processes we're asking them to execute on, to give them a way to check, have I done the appropriate amount of work? Knowing when they're done is really key, and knowing if they've done a good job. No one who puts work into anything that they're going to show to no one who puts work into anything wants it to be bad. They want it to be good. You want it to be a good threat model, but you don't necessarily have a good set of ways to judge that. And so we talk a lot about how do you validate the threat model, how do you validate the threats, and how do you tie this to the software development process through thinking about threats as bugs, thinking about mitigations as features which you can develop, so that the output of the threat model is really tied closely into the software development process. So for more on the SDL threat modeling, outside of Microsoft, there's an MSDN article, Threat Model, Uncover Security Design Flaws Using the Stride Approach, which talks about this, and a sort of dry academic paper talking about our experience as threat modeling at Microsoft. We published this last week. It's gotten some good pickup. People have liked it. And it talks about a lot of the drivers behind the decisions which we've made, why we've made those decisions, and what we see. And for those of you who are inside, the formal training URL is there. So having reviewed SDL threat modeling, I want to compare the approaches a little bit. And when you look at this, when you look at the actual steps which we've developed, we both start out with DFDs. We talk about diagramming. EMC talks about identifying attack surface. The differences are really small. EMC talks about threat identification with a library. We talk about identifying threats with Stride and some guidance. EMC talks about risk assessment within their threat modeling process. We look at the bug bar as an overall part of the SDL, not necessarily part of threat modeling. So the difference there is really how and when we assess risk. We're both doing it. We're doing it a little bit differently. EMC has gone a little more prescriptive in how they are suggesting threat mitigations than we do. I think it's that guidance is great stuff, and I think we're learning something from how they're doing that. And then the validation step, the difference there is really the structured approach in how we validate threat models, how we validate threats, how we validate mitigations. So these are remarkably similar. They're really, I think, some other differences that I want to just talk about quickly. EMC has maintained the complex process, multi-process element in their training, in their guidance of how to do things. We've maintained it in the tools for people who want to use it, but people came to me and said, Adam, when am I supposed to use which one of these? And I thought about it for a while, and I talked to some of my colleagues, and we could not come up with an easy-to-understand way to explain the difference. And so we said, why don't we just tell people to use the process and not, you want to use this because you've been using it for a while. We have people who have been doing formal threat modeling for a decade. Keep using it, but don't worry about the difference. Another difference is what we call our boundaries and how we talk about them. EMC talks about security controls. Microsoft's SDL talks about trust boundaries. I think this is actually a very interesting difference. I think it's one of the places where I would love to hear feedback of, as all of you are threat modeling, which of these works better for you? Have you tried using security controls? Does that work as you're actually deploying the process? Or do you like trust boundaries? Do you like that open-ended nature of saying these things are different and we'll talk about how at a later point in the process? Right now we just want to note that they're different. So in threat identification we have a shared goal. Letting non-experts identify issue types. And EMC does this with a set of weaknesses, and we do it with Stride categories and a set of leading questions that are in the threat modeling tool. The reasoning behind Stride, there's a couple of major reasons. One is evolution from past training. We've been telling people about Stride for a very long time. We have a lot of people who are very familiar with it. We have a lot of places in which Stride is built in a lot of bug databases, for example. The security effect, there is a drop-down that says, here are the Stride categories. And so it's become baked into our processes, And it's baked into our processes because it works, because it provides a framework for thinking about security. You've got these 6 threats. That structure is built into a lot of tools in a lot of places. It's built into the bug bars. It's extensible. You can say, oh yeah, this is another type of spoofing. And we hope it's evocative. It's hard to remember a list of 90 disparate threats or 150 disparate threats that might apply to a system. But Stride, you've got an acronym which you can remember. You've got threat classes which you get used to working with. And so it starts to work as a little bit of an evocative method for helping people think about what the threats are. And so one question that I've been looking at is, hey, can we actually overlap these? Do the EMC weaknesses map into Stride categories easily or well? I think is an interesting opportunity to move forward together. So overall, the thing that struck me was just how similar our approaches to threat modeling have become. That Danny and I met for the first time a couple of days ago. We're working in separate environments with different people, different cultures, and we've arrived at these very similar sets of pressures, which Danny outlined, about non-experts working, about a need for a methodology that was quick and easy and effective, about the need for buy-in from the people who we are asking to threat model, or at Microsoft telling to threat model. But I've tried very hard to believe that if I ask, if I say, this is how I would like you to do it, here's why I would like you to do it this way, and please tell me how it's working, that works a lot better than a stick. And so I've tried to take the approach of threat model how you'd like, and I recommend that you do it like this, and have been getting good results with that mix of carrot and stick. The other way in which I've tried to embrace usability is in the SDL threat modeling tool, where we've really put a tremendous focus, as we've developed and designed it, on what happens when someone picks this tool up for the first time. How is it that they will actually get through this process in a way where they feel reassured? And so I'm going to give you a demo in just a second. And as I do, I'm going to show you the way in which we're trying to make it easy to use, to make it a good experience for users. And so let me just pull up the SDL threat modeling tool. So when you start the threat modeling tool, one of the things that I saw in doing usability tests and interviews with the previous version, people didn't know where to start. There was this blank screen, and a lot of folks were just overwhelmed. Where do I go? What do I do? There's all of these things that I might touch. And so we've put in this sample diagram, and we've put help directly on the main page. It's right there in front of you so that you know, oh, I added up this diagram. We also have numbering down here. Step 1, Step 2, Step 3, Step 4. Now, as I edit the diagram, am I doing it right or not? Let's say I drop a data store in here, and I rename it as a database full of social security numbers. I have validation right down here. The data store has no connections. Data should come from outside the system. Okay, I get it. I'll draw a connection from the database to my process over here, and then the validator tells me, hey, data should be used by something outside the system. Nothing is reading from this. So these lessons, this feedback is data that, or issues that we saw over and over again when we actually reviewed threat models, and we've built in the common feedback so that as you're doing the work, you can actually get feedback directly from the tool. Now, as you go through and analyze your model, we remind you, hopefully you've seen the training, but if not, we tell you, hey, This data, it's a data store, or this database is a data store. It's subject to tampering, repudiation, information disclosure, and denial of service. If you're not really familiar with tampering, we've got guidance right here. Tampering is altering the bits in the data store. And so I can read through these and say, we might bill the wrong person, might be a threat. And I can't type and demo at the same time, so I won't. So I describe the threat, I describe the solution, and once I've done this, I can actually file a bug directly from the tool. And I can select Product Studio or Team Foundation Server. New here is Team Foundation Server. And my laptop actually died at about 4 p.m. yesterday. So I'm demoing with Brian's laptop, and Brian doesn't have TFS installed. But if he did, we would see TFS in this drop-down. This is a pluggable bug tracking interface, so that as we ship the tool out to the world, which we'll be doing next month, you can plug in whatever bug tracking system you're used to working with. It's a very simple API that allows you to do this and file bugs directly from your threat modeling. So it integrates, it pulls threat modeling into the development process with things that engineers are used to dealing with. And again, we've got instant feedback. No bug tracking system is chosen. Please select one. So I will cancel that. Now, we've been using this tool. We shipped the first beta to a very large product team back in June of 2007. So we've got a year or more of experience and feedback. And some of the feedback that's come back, and this is new in version 3.1, is people said, I want to draw these additional elements, but I don't actually want to have to threat model them. You know, you automatically generate these 6 threats. It's a little bit difficult to go through these 6 threats and say, for each one, no, I'm not worried about this. So I might say, hey, don't auto-generate threats for this because Mike is going to threat model it. And boom, all of those have gone away in the diagram page. It's been grayed out so you can see at a glance that we're not dealing with it. Another common request that we got was, hey, this data store here, it's not a log, so I don't care about repudiation. And we discovered this, and we had a slightly clunky system, which took 7 clicks, 2 dialog boxes had to come up. And so now we have the ability with 2 clicks, just certify, select a reason. And again, right down here below, there's advice on what am I doing here? Select a reason, explain it, and you're done. So I don't really need to explain this. Data store is not a log. But you might also say it's mitigated elsewhere, and so this is covered in Brian's threat model. Right, Brian? Brian left. I can assign work items to him. Excellent. So all threat modeling processes, you have some information, dependencies, assumptions, the sort of document header information, who's involved with this, who's responsible. And something else which is new in this version is we have a team leadership mode. And when you select the team leadership mode, what happens is you can actually edit the fields. So I can say, hey, we are not part of Windows. We don't have a Comp Central ID. But what we do want to do is we want to track new field 1. We want to track separately who's the dev owner, test owner, and PM owner. And so I can actually edit the fields. And then when I save this threat model, I'll be able to use it as a template, and anyone who opens this up will then see those fields. So if I put in here that, say, the PM owner is Adam, when we go into reporting, I'll show you that the fields actually rotate all the way through. You also have the ability, this is something a lot of people asked for, my team would like more specific guidance. So we have the ability, you can load up an XML file, and I'm not going to drag you through the details of the XML. It's pretty self-explanatory. But all of the questions which show up here now come out of an XML file which you can edit so that as a team leader who's responsible for threat modeling on your product, you can put in your own sets of questions, and you can say, this is the default place I want these threat models to be saved. And when you save it, it will go there. It will default to that place. So like any sort of tool, our threat modeling tool has a set of reports. There's a threat model report which contains all of that doc header information and your diagrams and all of your threats. There's an analysis report which can help you understand what has been filled in. Hey, there's no diagram validation messages. There are lots of empty threats. There are these threats that have been filled out but not mitigated. There's a diagram-only report. And then finally, there's a recommended fuzzing report. And what this does, and I'll just bring up this thumbnail to remind you what the diagram looks like, is we're working to integrate threat modeling as not only a part of the SDL when you look at the process diagrams, but really begin to integrate together some of the tooling so that people come to us and say, hey, what do I fuzz first? Where do I start my fuzzing? Well, you've given us an architectural diagram. We can actually use the information in that diagram to provide you with advice. What's priority one? Stuff coming off an external entity and crossing a trust boundary. Priority two is other things which cross a trust boundary but might be seen to be as internal. So this is the SDL threat modeling tool, and I am very proud, very happy to announce that we have a release candidate which is available today. It is an internal release candidate. We'll be sending it out to the world after a little bit of pounding on it. I'm sure everyone will be kind and take a look, report bugs, tell me where we can improve. And so that's on the share SWI Tools Beta Threat Modeling. So with that, I will say thank you, invite Danny back out here, and we are both happy to take questions.
Thank you very much, Adam.